everybody, this is Giulia from Italy, and I'm in my classroom. So now let me just start my lesson. I'm going to think about the square of the binomial. So the lesson today is about special products. So let's write special products. And today we will speak about this kind of product. We have a plus b squared. And normally students solve this in this way. A squared plus b squared. And this is something that maybe seems to be smart. And it could be because if we think about this object, a monomial, and we square this, in this case the result is correct, a square b squared, because this means ab times ab, so we have a squared and b squared, and this is correct. But in this case this is not correct, because there's something missing, and normally we can understand this if we consider a geometric representation of all this, because we can consider a square, just a square. It can be maybe the plan of your room, your bedroom, for example, and the thing you have to do is considering two parts of this square. So each edge must be divided in two parts. The first part, the small one, maybe it's A, and the bigger one is B. So we do the same thing for all the edges, and we divide them in the same way. A, B, A, B, A, B. So now we can see that if we consider the area of this square, we see that we have this term here, this part of the room. If this is the pavement, the floor of the room, if we put a square here, we cover all this part, and then we put b square here. B square is all this part. But what we can see from the geometric representation is that a square plus b square doesn't cover all the square whose edge is
we
a
are solving
the square of a binomial, but there are two terms which are actually rectangular, and these two terms can be considered just something that we have to add when we have a sum. Of course, there is also another explanation, which is an algebraic explanation that we can give about this, and we can do it in this way, just solving the square in this way, a plus b times a plus b, and applying the distributive property, we do these things and then these things here. We multiply each of the terms of the first parenthesis for all of the terms in the second parenthesis. So here we have a times a, which is a square, and it is what we wanted. But then there is a times b, which is ab, and b times a, which, if we put the letters in order, in alphabetical order, it is ab. And then we have b times b, which is b squared. And so these two terms are the two terms that normally students put at the beginning. But now we can see that algebraically, we can see that there are two other terms. And what are they? Why are there these two terms? Because algebra normally doesn't give a great explanation. But if we look here at the plant of our room, and we see that a square plus b square they cover only a part of this plant. But there is another part here, which is a rectangular with base b and height a, and the area is ab. And this one, it has base A, height B, so the area is AB, all the same. And there we have two of these rectangulars, and they are the same, so we can sum them up and we can have these two terms. And so we have a term that we have to add here, which is the double product of the first times the second. 2 times first term and second term. And we can generalize this and consider this in a different way, or we can consider this just as a normal exercise. Anyway, always think about your room. If you put 2 squares, you don't cover all the area of your room. Okay, thank you for your attention, and I love to be your student. I love you to be my students. I love to be your coach and teacher. Okay, see you. I love you all.